welcome everybody. I'm glad to be here. I've met many of you, and this is maybe the first time you've seen me speak as well. I'm going to be, let's get on to that, presenting our first two basic parameters. So you can join this in your first year, and that's Secchi disk transparency or water clarity and spring and summer total phosphorus. A quick introduction of myself. My name is Erick Elgin. I'm an aquatic ecologist with MSU Extension. I work on promoting the protection and restoration of our inland lakes around the state. And the CLMP program is a major part of my work. And as Joe mentioned, I'm the lake program manager. The quickest of backgrounds, I've been working on lakes for a long time in different components. I started my career in doing a lot of shoreline restorations, and you can see that in the top left corner, putting in bioengineering projects to take away seawalls and harden shorelines and make them more natural, which has lots of benefits. I then really got into aquatic plants, which if you know me, you know that I love aquatic plants. And so that you see me diving in the middle of those white water lilies looking for different species. I also did a lot of food web work, and that's this depiction down here when there's no fish in a lake or when there are fish in a lake. What does that do for the lake ecosystem? And then now today, where I am using all of that, that background work and promoting that now to lakes across the state. So I'm going to first start, before I get into protocols, I'll give a little bit more background on the CLMP, kind of going off of what Tamara started, and then give a brief background on the parameters that you can choose from within the CLMP program. And then I'm going to go into our different protocols for the next hour or so. So like Tamara mentioned, we are the second oldest program, lake monitoring citizen science program in the United States. We started back all the way back in 1974, where we weren't called the CLMP back then. We were the self-help program, and it was focused on Secchi disk. And then through the years, we've added multiple other parameters. So spring and summer phosphorus in the middle 90s, in 2000, adding dissolved oxygen and temperature. And then in the 2000s, adding aquatic plant parameters and a natural shoreline or shoreline parameter called score the shore. Kind of to emphasize what Tamara said, is this is a great program where our goal is to create this great volunteer framework that gives us reliable long-term baseline data. Long-term is very important here because having data back from the 70s, there are some lakes, by the way, that have taken that have Secchi disk since 1974. And that data can tell us a tremendous amount. Yearly data or annual data is great, but when you can tie annual data together year after year after year, that can really give you a great understanding of your lake. As well as if you're trying to manage the lake, or if there's an invasive species that comes in, or whatever it may be, you can have reliable, scientifically valid data that can help guide your decisions. This is a monitoring program and not a management program, but obviously they're tied together. So it helps improve hopefully it helps improve our management of our lakes. And we have these great online database that is key. Oftentimes data might get put onto a report or a piece of paper, and that piece of paper gets put into a desk somewhere. And although maybe your lake has had Secchi disk collected through the years, it's not put into one location. And so it becomes kind of hard to see the trends through time. And so this online database is very valuable. And of course, our goal is to create scientifically valid data. And so therefore training opportunities are very important. Just emphasize again that this is a monitoring first program. So although that blends into the management world, we are focused on creating great monitoring data, and management is more of a secondary to this program. So as Tamara mentioned, and that database, you can find what we call on the data exchange. So here's our header in our mycore.net website, and looking at data exchange. So you can find, for example, here's Angela Lake in Oakland County, and you can see the data is all there. You can also bulk download all of the data into Excel, an Excel spreadsheet, which is helpful if you want to look at your data yourself. We also have a tremendous amount of resources, as we've already alluded to, within our website. We have fact sheets for each parameter. We have a full protocol manual. We have quick protocols as well, if you just need to have a quick cheat sheet. We have all historical CLMP reports for each lake and annually for the program as a whole. We have all of the things that need to be known for each of these parameters you're going to learn about today. Including timing, when to turn in, where to turn in samples, and all of that. And of course, training videos. We do have 2021 training videos up right now, which are still great. And as Joe mentioned, within a week or so, we'll have this training up as well. And if you find yourself on mycore.net and you want to find where all of these documents are, so go to mycore.net. Click on Lake Monitoring on the top toolbar, and then move down to CLMP documents. The parameters we choose are quite wide and tell us a lot of different components of our lake ecosystems. We have water clarity and total phosphorus, which I'll be talking about here in a moment. We also have chlorophyll A, which is a proxy measurement for algae. So if you're interested in knowing how much algae is in your lake through the seasons and through the years, chlorophyll A is a great parameter for that. Dissolved oxygen and temperature are tied together because they use the same meter. And this is where we check the temperature and oxygen throughout the lake profile. And Tamara will be talking about that soon. And then we have two aquatic plant parameters, one being a full aquatic plant survey where we look at native and invasive plants and where they are around the entire lake. And then we have an early detection parameter called the exotic aquatic plant watch. And that where we look in specific locations to try to find a new invasive species before they become fully established around the lake. And then shorelines are really important because the biggest stressor on our lakes right now in Michigan is the loss of shoreline habitat. And so having quality baseline data about what is happening on your lake is really helpful in making future decisions. And I'm just going to give a brief description of these three parameters and what we use them for. Paul will be going into more detail, and this is just a precursor to that. But these three parameters, water clarity, total phosphorus, and chlorophyll A, are used individually and in combination to determine the trophic status of your lake. And so what does that mean? Trophic status is the description of how productive of a lake is. And what does that mean? Well, this is a classification system that puts your lake into a spectrum of, is your lake low productivity, meaning low amounts of algae, low amounts of growth, low amounts of plants, all the way up to a lake that has a lot of algae or a lot of plants. And those, they're not just full out buckets. It is definitely a spectrum. You can be in between, for example, trophic statuses, but they can tell you there's a lot of value in classifying lakes this way, especially through time, as we know a lot about each of these. And so Secchi disk, total phosphorus, and chlorophyll A are used to tell if your lake is oligotrophic, meaning low productivity, low amounts of algae, to mesotrophic, which is in the middle zone. It's not excessive amounts of nutrients, which creates excessive amounts of algae and plants. It's more of in the middle. And then going to eutrophic, which typically is very productive, not just with plants and algae, but then also with fish and other parts of the lake ecosystem or lake food web. Lakes fall naturally in all three of these trophic statuses, so there's not a goal to be one or the other necessarily. It just depends on your geology and a few other things on what your base trophic status is. So I just want to conclude this part in saying there's a tremendous amount of benefit to long-term monitoring in lakes and streams. You really can capture the history of your lake, which can then help motivate what we do in the present. And this is just an example timeline where here's a lake through time when in the 30s, maybe the first cottages are built. The CLMP began in the 70s, so you started collecting Secchi disc, for example. And then you have different things that occur through time. Maybe in the 80s, Eurasian water milfoil invades. Maybe in the 90s, the cottages are kind of being changed to full-time residences, which has new stressors on the lake. Zebra mussels maybe invade in the early 2000s, and then shoreline continues to harden. Maybe also you get a sewer installed later, and having this long-term data can really tell you the benefits, the impacts, or no change that can occur in your lake. And without that data, we would be using an eye test instead. And it's hard, our memories don't serve us very well when we're thinking back in time. And so having great data is very beneficial. Okay, let's get into the Secchi disc water transparency protocol. This is a Secchi disc here, and this is a simple white disc. It can white and black disc that's 8 inches. It was developed in the 1800s to measure the water clarity of the Mediterranean Sea. And this now super simple tool has been is now considered the standard for measuring water clarity across the world. It's great because now when we collect water clarity with this method here in Michigan, somebody in Argentina can look at our data and fully understand it, and then also replicate it over there. And now we can compare the data well. So this very simple disc is really important to the field of limnology or lake science. So how does it work? Well, so you have a disc on a rope, and this rope has markings on it for, depending on what it is, it could be by feet or it could be by meters. And so in clear water, you drop the Secchi disc into the water and you can see it a ways down. You can see it quite deep. But now if there is cloudy water due to algae or suspended sediments, or the watercolor itself, you may have a root beer stained lake, the Secchi disc won't be able to go down as far, and your measurement is less. Secchi disc transparency is, although you'd think, well, it's water clarity, what does it tell us? Well, it can tell us a whole lot about our lake. It's like a simple test that gives us the pulse of what is happening. It can be an early warning sign of changes that are occurring around the lake or on the lake, where different processes that are taking place, changes in the food web or more nutrients occurring, can all affect water clarity. Some lakes become less clear through time, and that could be caused by eutrophication or the increase of algae and plant growth in a lake. It can be caused by re-oligotrophication. So that's a big word, but really it's the change from a eutrophic lake to a more oligotrophic lake. So high productivity to low productivity. And that can happen because of zebra mussel invasion, for example. Or it can be caused by browning, where your lake is becoming more tea stained or more root beer stained. So when we collect Secchi disc water transparency with the CLMP program, we have you collect samples throughout this growing season from May to September, multiple times a month, and then hopefully through the years. So monitoring water clarity through the season is really interesting because you can see changes that occur through the months. So Secchi disc is often looked at on an inverted graph is what it's called. So the top of you can think of the top of the lake is at 0. You can see the angler here fishing on the top of the lake, and the fish is going deeper and deeper. So this is 25 feet down here, for example. So it's flipped. And what this is indicating is that in May, for example, water clarity measured by Secchi disc is maybe around 17 feet. But in June, it decreases to only 12 feet, and then July being around 5 feet, and then some variability into the later months. This can tell us a whole lot about what's happening in your lake. This deep Secchi disk could be caused by something called the spring clearwater phase, and it's a nice, cool phenomenon by a little critter called Daphnia. And this July could be because it's the heat of the summer and there's plentiful nutrients that you have a lot of algae in the water, or it could be caused by stirring up of sediment caused by a lot of boating activity around the 4th of July. And then, of course, when you start to look at the water clarity through time, this can now tell you how your lake is changing. So this particular lake was eutrophic in the 70s and early 80s, but then changes in management that occurred moved it into a mesotrophic and maybe sometimes into the oligotrophic state, trophic status. So let's go into our requirements, our protocol requirements. We require evenly spaced monitoring through the middle of May to the middle of September. So that oftentimes is once every 2 weeks to collect water clarity. That equals at least 8 measurements. Now, if you want to collect water clarity every week, you are more than welcome to do so. Something that we find is that water clarity is one of our more popular parameters because it's amazing how much it changes weekly or bi-weekly. And so people are really interested in it. Some CLMP volunteers post their measurements on their Facebook page, if they have a Facebook page for their lake association. And people seek it out because they want to know what's our water clarity this week. So it's although it seems fairly simple, it's an exciting parameter. So here's our protocol. So our step 1 is that you drift your boat approximately over the deepest part of the lake. We don't need you under exactly the deepest location, but near the deepest location. And we have you drift your boat over that location and not anchor if you can, because what happens there is if your anchor hits the bottom, it will resuspend sediments up. And so if you know kind of approximately where that deepest location is and you do need to anchor, you would put the anchor down while there's still some forward momentum to get away from that sediment plume from the bottom being hit by the anchor, because you don't want that to change your water clarity. If you're interested in where if you're not sure where the deepest location is, we have the field ID or lake sampling site that you can find on our website for your lake. You go to mycore.net, lake monitoring, and then CLMP documents, and you can get this page where, for example, on Cedar and Elkona, here's the latitude and longitude of approximately the deepest location on the lake. Well, let's say that's you don't have that, and we don't have it on this list. You can look at what's called a bathymetry map, and this is essentially a topography map for a lake that shows how deep it is. And so you can see here's a 20-foot location and here's a 25-foot location. And so we would ask you to collect your Secchi disk in somewhere in this deepest location of the lake. Oftentimes we have a question on why the deepest location and why not all over the lake. Well, so technically you could do it all over the lake. That can tell you specific locations. If you have a stream coming in, you could take Secchi so you have an understanding of that. But we're trying to collect baseline data that is comparable through the years. And the standard for that is at the deepest locations or the deepest location within a lake. So that is standard across Michigan for the CLMP, as well as other monitoring programs across the world. So step 2. So now you're over that deepest location. Now you slowly lower the disk until it disappears from view. So slowly look, make sure you don't have sunglasses on, and look, because sunglasses will change the ability of how far you can see. So you want to use your naked eye. Of course, if you have glasses, you can use glasses. When the disk disappears from sight, you note the depth on you have a nice tape measure here. Note the depth right at the water level at which the disk disappears. And then step 3, you then slowly raise up the disk until it reappears again. So that should be fairly quick. Now you note that depth. So you've noted the depth that it disappears, and step 3, you note the depth that it reappears. Step 4 is that the official measurement is the average of those two depths. So average those two depths, round to the nearest half foot, and you would record that number on your data sheet. So again, a couple things to remember: don't use sunglasses. That can impact how far you see, and then therefore would give you inconsistent measurements through time. Because let's say you have sunglasses on one time and you don't another. So we want to have consistency with our long-term monitoring. Also, pick the shadow side of the boat. If you're doing this at high noon, that's not as, that becomes problematic because there's really no shadow, but you want to be consistent. And if you go on the sunny side of the boat, you can get a lot of reflection off of the surface of the water, and that'll impact how far you can see it. Try to be consistent in your weather and timing. So measure between 10 and 4 p.m. This is important because if you go out at 8 a.m. or if you go out at 7 p.m., the sun is at a much greater angle, and that can impact how far you can see the Secchi disk. Try to be on sunny, calm days. Those are the best. And do not measure during heavy boating. So like I said, if you did this on 4th of July on a heavy recreation lake, that'll have sediments resuspended up into the water column. And that'll give you an artificial measure of what is happening with water clarity on that day or during that time, or at least give a couple days after. So also what contributes to us having Secchi disk measures throughout time on a particular lake is because the algae community is quite dynamic. There are many species of algae, many groups of algae, and when they do well, when they explode in population, changes with the seasons, depending on temperature, light availability, and nutrient availability, and competition with each other. And so what we see here, for example, down here, right after ice off, you can have an algae called diatoms bloom, but then they crash, and another group of algae called green algae will increase, and then those kind of go down, and blue greens, which are adapted to live in warm, nutrient-rich conditions, but can fix nitrogen from the atmosphere. They can take over later in the season. And then you have diatoms returning when the water is a little cold and the lake is mixing. So we want to capture this variability to give us the best glimpse of what is happening with water clarity in your lake. Here's our form. Note some of your lakes are going to be really clear and some of your lakes are going to be really shallow. And so if it's really clear and shallow, your Secchi disk might be on the bottom. Don't just put Secchi depth to be, let's say it's 10 feet, without giving a note that it's on the bottom, because that's not a fully true Secchi disk reading. So put down what you have, but then note that Secchi disk is on the bottom of the lake. That is really important. We give you the dates that you should be sampling every other week or every 2 weeks. We give you those sampling intervals. On the back of the map, we do like to have a hand-drawn map. You can paste a map on there of your lake and approximately where you did the sampling. And then, of course, and you'll hear this over and over again with our different parameters, is that for this, we don't need anything back except for the data sheet. And so please make a copy of your field data sheet to keep for your records, and then mail one copy to us by October 31st to this address, and this is on each data form. Or if you're going to send an electronic copy, please send to mycore@msu.edu. We encourage that everyone. So we have the data on the form, but now we need to get into the database. We encourage all volunteers to enter their data online. This gives them instant gratification because it's up there, where it would take our team a little while to get everything up. So please, if you can, enter your own data, but we can do that if you cannot. And we have all the instructions on data submission at our website. And once again, you can do all that with the MyCore data exchange, where all of the data is held. You also receive a data report, usually in the early in the following year, which compiles all the different parameters that you collected in the previous year with some broad recommendations. And then just to hit it home, it's wonderful to have long-term data. Here's an example of what you would get from us, where the blue dots are the average for the year. And then this is the error bars or standard deviation, the amount of variability that you have. And you can see in this particular lake that the water clarity has been increasing. Or you can see where, since this program has been going on for so long, there may have been volunteers collecting data back in the day, and then nothing for many years until a volunteer gets interested again. And so it's great if you're collecting data this year for the first time. I would encourage you to look in our website to find out if the lake has collected in the past. And if you need help with that, please let me know. So we'll take a moment here to ask any questions, answer any questions, and then we'll go into the total phosphorus.
Thanks, Eric. We do have a few questions that have come in the chat, so I will pose those to you now.
All right.
So if someone is totally new to the program and wants to sign up to monitor Secchi, what can they do?
You can enroll today. Our deadline is actually today for Secchi Disc at midnight, but feel free to contact me and let me know if that's impractical. But so you would go onto mycore.net and you would click on Become a Volunteer, and you would make you'd go in and sign up as yourself, like you do for like Amazon or other online programs. And then you would click on your lake and you would sign up for Secchi Disc. Secchi Disc does, like all of our parameters, have a small fee. And so you'd pay $30 to join the parameter. And if you don't have a Secchi Disc, you can buy it from us for $60.
Thanks, Eric. Next question. Is it best to monitor Secchi Disc transparency when there's no other activity on the lake, like fishing?
Well, fishing is typically not too dramatic. Now, if it's a fishing tournament and there's a lot of boating activity all at once, that can make some stirring effects on the bottom sediments. But it's okay if you're out and there's some activity on your lake. It's more of those heavy boating activities where you want to stay away from a day or two after.
All right, thanks. Just a couple more questions. One of them is, what if our lake is not listed on the lake sampling site?
Contact us and we will look into what needs to happen there. It may be missing for multiple reasons, so please contact us and we'll go from there.
All right, one last question about data entry. If we enter the data online, do we need to mail the forms via postal mail as well?
Yes, it's good data quality control to have original data sheets or copies of the original data sheets, but you are free to email those data sheets. But yes, we do want the data sheets.
Right, so send a hard copy, or you can send an image of them via email, as long as we get some kind of copy of your data sheet, right?
That's right.
Perfect. All right, that's all the questions, Eric, so you can continue.
Excellent. All right, let's rock into spring and summer total phosphorus. For folks who have been in the program for a while, these bottles look very familiar, and for new folks, you'll become familiar with these bottles. So first, a little bit of why phosphorus. So phosphorus is an essential nutrient in our lake ecosystems. They, along with light, fuel photosynthesis or photosynthetic activity. So our algae and plants require phosphorus, and phosphorus is often the limiting nutrient to their growth. And so what that means is if there's all the other nutrient requirements in a water body, it's still phosphorus that will be limiting how much they grow and reproduce. And so phosphorus is a really important component in our lake ecosystems. Now, it is also problematic because our activities around a lake, on the shoreline directly or up in its watershed, can greatly increase the amount of phosphorus entering our water bodies. And this is called cultural eutrophication. And so what's happening here is our activities, like I mentioned in the watershed around a lake, increases the amount of phosphorus that enters into a lake. That phosphorus is used up by algae and plants, and you can get some ecological negative impacts to a lake, as well as impacts to us as well. And so you can have higher algal biomass, possibly harmful algal blooms. You have reduced aesthetics, all of that reproduction and growth of algae at the surface of the lake. Well, those algal cells die, fall to the bottom, and when they're decomposed, that process uses oxygen. And so that can actually decrease the amount of oxygen in the bottom parts of your lake, which can cause issues for fish habitat, as well as chemical processes that can occur. And there's also, when water clarity goes down because of an increased amount of algae, you can even have a reduced economic value of your home. And so phosphorus is really important to look through the years, because if you see changes in it, positive or negative, that can change what type of management is occurring around your lake and on your lake. And I wanted to put one more thing on there because it's in the news a lot, and that's harmful algal blooms. They are also called blue-green algae or cyanobacteria. These are bacteria that can produce toxins, and these toxins can be harmful to our pets and us. And so this is a picture of the famous picture from Lake Erie that shut down the Toledo water intake because of the toxins present from these algae. And these algae can proliferate due to the large amount of nutrients in the water, including phosphorus. We still have a lot to learn about why they produce toxins and when they produce toxins, but that's something that's on our minds. Measurements through time are important. If I haven't motivated you enough, but we have two types of phosphorus that we collect: spring phosphorus and summer phosphorus. And you can see some graphs here that we create. So here's an example from a lake and showing the trends of phosphorus through time. You know, if your lake is becoming dramatically higher in phosphorus, that could trigger action to help mitigate that loading of phosphorus. Or if phosphorus is declining, that might mean that some things are working on your lake. Yeah, so let's get into the protocol. What you get in the mail. So let's start with that, because for each parameter you get something from Gene Roth, who is the master of getting all this information and equipment out. So you'll get the monitoring instructions, the sampling and sample turn-in schedule and location. So we call that the phosphorus schedule. That's really important because that gives you when to collect and where to drop off. We give you a data form, we give you bottle labels that must be used, and you get 3 of them. So in case one gets lost or gets messed up, and you get 2 sampling bottles with caps on. We use one for the actual sample, but we have 2 collected because we will use some randomly as a replicate to double check the quality of our data. Other materials needed, but we don't provide, is a cooler bag, ice pack, Ziploc baggies of different sizes, and a pencil or Sharpie. And I always mention pencil or Sharpie. So it's important when you draw or when you write on these labels that it's not from ink that will smear when getting wet. So pencils won't do it. And then there are certain markers or pens that will not wipe off once they're applied. And that's really important. Without being able to read the label, we can't accept the bottle or the sample. So let's first get into spring overturn. So by this point, the lower peninsula has likely already collected their spring phosphorus if you are signed up for it. This is because we collect the spring phosphorus sample within 14 days after ice out. So that ends up being March, April, or May. If you're up in the UP, I just heard ice is coming off in Iron County, so you may be collecting it this week. And I'd be curious if anyone's on here from the UP, feel free to let me know, just out of curiosity. Is ice out yet? So we can't determine when your lake becomes ice out because it changes by latitude, but then also by the type of lake, if it's small, large, shallow, deep. So the volunteer determines ice out and has to record that ice out on the data sheet. These spring and summer phosphorus are all grab samples from the surface. And I'll show you what I mean by that. And this spring sample is important because it gives us a representation of the phosphorus within the entire lake. And why that is because in the springtime after ice out, the lake is fully mixing. We don't have stratification. Tamara will go into that. But in the spring, the temperature is the same or about the same from the top to the bottom. And all of the lake is easily mixed by wind. And so that grab sample at the surface can kind of tell us a representation of what's the concentration in the lake. And it's great to show nutrient trends through time, the spring phosphorus is. Summer stratification or summer phosphorus is taken during summer, the peak of summer stratification, which means August or September. It depends on your latitude. So this is where you will have to go to the phosphorus schedule and learn for your county at what time do you collect that sample. And again, it depends on the latitude. This is also a surface grab sample, the same method that we do for the spring. And this phosphorus sample is used to calculate trophic status and also can inform us about external loading of phosphorus. If there's a problem with with external loading, so phosphorus entering your system from the watershed or shoreline, this sample can indicate to us if there might be an issue. So this is the schedule. This is a clip of the schedule. Of course, we'll have for every county. So look at which county your lake is a part of, and then it tells you your sampling date. So for example, if you're in Allegan, and we're in summer phosphorus now, so Allegan County, you would collect in these days between September 22nd and 26th, and then you would turn it in the day after between 8 and noon at this location. For spring phosphorus, the turn-in date for all lakes is June 21st. So June 21st, look at the spring phosphorus schedule and you'll find the locations to where to turn it off or drop it off between 8 and noon. Just an example for summer phosphorus is UP lakes will be collecting in August and southern counties in Michigan will be the end of September, just to give you a little bit of perspective. Labels are really important. So let's get into the actual step-by-step protocol. So step 1, before you put the bottle in water, before you do anything, fill out the labels. So we have this in our protocols. So please take a peek at that. But what we want on here is to have your initials, the date you collect the sample, your field ID for the lake. And if you can't find that field ID, please contact us. The location, so your lake name. For the analysis or parameter code, please write GA, and leave chemicals added blank. Now we have 2 bottles, and so the second bottle, what we would like is the addition of rep on the location. So still have your lake name, but then add rep, and that is for your second bottle. So you have you have our 1 true sample and then a replicate of that. Make sure to use pencil or permanent marker that doesn't smear. permanent marker, permanent pen, anything that does not smear, and fill that out before it goes into the water. Otherwise, the sticker may not stick very nicely. So step 2, drift your boat over the deepest part of the lake, just like you would do for Secchi disc. Try not to kick up any sediments because that can also change your phosphorus. Remove the cap. So I should mention this. So these bottles are specifically cleaned for the measurement of total phosphorus. Total phosphorus can be very sensitive. If you're in a lake that is oligotrophic, so that's that low productivity lake, a hair or dandruff and dust falling into the bottle can start to change, could possibly change the measurements. And so leave the cap on until you're ready to do the sampling. And so take that cap off, make sure everything stays really clean, drift over. And now what we want to do, just in case there's some particles in that bottle, we are going to rinse with the lake water twice. So holding the bottle at the bottom of the bottle with your hands, put it in, get some water in there, swirl it around, dump it out. Do that twice. Use only the bottles that we provide. So we will not accept phosphorus in any other bottles because, again, these have been cleaned specifically for phosphorus sampling. Just make sure not to contaminate the bottle or the cap. So that's important. So when you take the cap off, I've seen where sometimes, or I've done it with all my sampling I've done in the past, I put the bottle cap on the bottom of the boat, and then my muddy shoes will get mud in there. And at that point, that's problematic. So make sure I would have to rinse that out very well, or just make sure it doesn't get a dirty foot on it. Step 3 is actually taking the sample. So you fill the bottle by lowering it upside down below the surface to around 1 to 2 feet of depth. So that's kind of your elbow, and then tilt it upwards. You'll get the bubbles coming, and then you have it filled up. Do that twice. So one, you do it with your first bottle and then your replicate bottle. Because we freeze these, so you'll be collecting this water and then we freeze them. So step 4 is to pour out some of the water. And I would go maybe even a little lower than this because we don't want a cracked bottle. If we had it totally full and we froze it, it would burst the cap open and we wouldn't be able to use the sample. So drop some of the water, empty out some of the water, and then cap it and freeze it. Step 5 is place those labeled bottles into a labeled baggie. And so that would be date, lake name, and say total phosphorus, and place it into a cooler. Step 6 is fill out the data sheets. They're fairly simple for phosphorus, and then make a copy of that data sheet or take a picture of it so you have your own copy, then fold it up and put that into its own baggie, and you can slip it into the frozen bottle baggie. So I said baggie a lot in those couple sentences. It's more, make sure the data sheet is in its own Ziploc bag, mainly because if it's not, and if it's touching the bottles on itself, that paper will disintegrate, or we have to, when we take it out, we have to hang it up and have it air dry on a little clothesline, hoping that it doesn't just shred apart. So that's why we want the data sheet in its own bag. Like I mentioned, the data sheet is fairly straightforward, where we just have our typical lake name, county, township, the field ID number, if you have latitude, longitude, or if it's just on the map, the names of you and your assisting volunteers. For the spring, we ask for that date of ice out, and then we ask for other conditions. Feel free if there's some strange conditions, we have a comments box, or if you see something, feel free to write it in there to give us a clue on what may have happened to that sample if we get a weird result. And then of course, the same as the Secchi, fill out the back, approximately where you sampled. And then we would like the same thing where, please send your data sheet with your bottles. Step 7, you now have everything. You're back at your house. Please store in the freezer until your turn-in date. So for spring, that is quite a ways. You may have collected in March, and please keep it in your freezer until the June date. And for your summer sample, that won't be very long at all in your freezer. So, and then that ends in with turning it in, turning your frozen bottles with your data forms to the designated location on the phosphorus schedule. So that's that earlier document that I showed. So just kind of coming to the end to talk about what could go wrong. One of the big things is that phosphorus is collected at the wrong time. So for spring phosphorus, if samples are collected beyond 2 weeks after ice out, we'll flag it for potential error. If it's collected over 4 weeks after ice out, we'll reject it altogether and it won't be analyzed. This is for data quality and consistency is why we're strict with this, because phosphorus 4 weeks after ice off may be very different from 2 weeks because stratification may be setting in. For summer phosphorus, it's very much the same way. We have that time period where you should be collecting. If you collect more than a week outside of that interval, we will reject that sample. We also have what may happen sometimes is incorrect delivery. If you forget or something happens and you can't turn your samples to the drop-off location on the specific date, that can cause problems. We could lose a sample, for example. So please contact us. If you cannot make that June date, for example, or the summer drop-off date, please contact us and we can arrange a way for that sample to get to us correctly. We don't want a sample dropped off somewhere and thaw fully for a couple days before we get it, because at that point we would have to reject that sample. And of course, another way is that we reject samples if it's cracked. So make sure to pour out a little bit of that water so that when you freeze it, when the water expands, it doesn't crack the bottle. And to emphasize, we do not want to see any other bottle other than the bottles that we provide. We only accept those sterile bottles. And by the way, those bottles Jean sends out when it gets closer to the dates. So when it's close to the spring phosphorus, she sends those out to everybody. And when it's close to the summer sampling days, she will send those bottles to the lead volunteers' addresses. So to see phosphorus through time, just like Secchi, is so valuable to see, because if you just had one sample, it doesn't tell you much. But now through the years, we can start to have a trend where we can see, for example, Corey Lake in St. Joseph County has a minor downward trend, although it's fairly flat as well. To conclude this part, this is an important piece of all of our protocols, is making sure that we don't move invasive species between water bodies. We are trying to help our water bodies, our lakes, and we don't want to be the cause of spread. So please follow the decontamination or protection phrase of clean, drain, dry. Clean off your gear between going into different water bodies, drain any bilge pumps or buckets that you may have with water, and dry off your gear, or let it dry for multiple days so that if anything got onto our watercraft or gear, that they won't transfer to another water body. So thank you very much. There's the first two protocols, Secchi disc, transparency, and spring and summer phosphorus. Are there any questions?
Yes, there are a few questions, but first I wanted to share a couple of responses we got to your question, Eric, which was about ice out in the UP. We had a couple of comments from that. We heard that from Bruce on Fortune Lake in Iron County, their ice came out last Tuesday, so about a week ago.
Perfect.
And Denise shared that on Bass Lake in Marquette County, ice out happened 9 days ago. So pretty recent. Pretty recent.
And that's incredible, because we've had folks in Southern Michigan collect it many weeks prior. So that's great.
Absolutely.
That's what's fun being it's fun to be a statewide program.
Absolutely. A question from Sarah. We signed up for spring phosphorus, but had transportation issues getting the boat on the lake and we couldn't get our samples. Ice off happened in April. Is there any value in still trying to get a sample?
If it was the beginning of April, no. If it was April 31st, you might still be in that 2-week window. So if you are within that 2-week window, please still take it. But yeah, if it's been over a month, then there's no value. We would not even analyze that sample.
All right, thanks. Next question. I think you covered this after it was asked, but Craig asked, if turn-in for spring sample is in June, how do I properly store my sample until then?
Well, thanks for, yes, we keep it frozen. So it comes off the lake, make sure everything's in its baggie and labeled nicely, and make sure there's all that headspace in there, and put it in the freezer until that turn-in date. We want to keep it frozen by the time it gets to our drop-off locations.
Great. Yep, that's super important. And I have a question that relates a little bit more to interpretation of the data. Mark mentions that their summer phosphorus that they recorded last year was significantly higher, in his opinion, from past years. Is there a recommendation as how to respond to this?
Yeah, interesting. So you can reach out to us and we can have a discussion about the data and what it may mean. And then there could be avenues from that discussion. For example, getting a high phosphorus measurement. If it's still if it's a realistic number, meaning it's possible that it doesn't look like it's an error and it's like 1,000 milligrams per liter and it's something really high. But if it's reasonable but high for your lake, it may be because it was collected after a major rain event where a lot of runoff came off of the watershed and increased the phosphorus in the top part of the lake for that part of the season. So we would kind of walk through those scenarios that it could be and then go from there.